Assalamualaikum. My name is Wan Muhammad Irfan bin Wad Abdul Syukur. Number matric 13 DKM 24F 1042.
Hi everyone, my name is Syed Ahmad Aiman Shah bin Syed Ahmad Ridwan. My metric number is 13 DKM 24F 1054.
Hi, I'm Adam Hakimi bin Azizan and my metric number is 13 DKM 24F 1103. Today, our group will talk about the installation of milling machine.
A milling machine is a versatile machine tool designed to remove material from workpiece by feeding it against a rotating multi-point cutting tool known as milling cutter. It can perform a wide variety of operations such as cutting flat surfaces, grooves, slots, gears, and complex 3D shapes. Milling machines are widely used in manufacturing, metalworking, and mechanical engineering because they provide high precision, accuracy, and flexibility in shaping different materials. First, site inspection. Before any works begin, we must perform a walkthrough of the proposed location. This includes checking access routes for delivery and crane placement, confirming floor condition and load capacity, verifying clearances around the machine for maintenance and ventilation, and assessing any environmental factors such as dust or moisture. We should identify potential hazards, including existing utilities, and any structural elements that might interfere with installation. Document our findings with photo and notes, then share them with team so everyone understands site constraint. Second, foundation setup. The machine's foundation must meet the manufacturer's specification for load distribution and vibration isolation. Determine whether a reinforced concrete pad or bolted steel base is required, and confirm dimension, levelness, tolerance, and curing time. Ensure anchor bolts, location, and embedment depth are marked and verified. If isolation mounts are specified, decide their placement and stiffness rating now. Coordinate with civil team to schedule pouring and curing so installation isn't delayed. Third, power requirements. Confirm the electrical supply type, voltage, number of phases, and expected load. Verify that incoming cabling, breakers, and grounding meet both machine requirements and local code. Plan the routing from main distribution to the machine, and ensure disconnects and protective devices are accessible. If the machine requires a dedicated transformer, soft starter, or surge protection, specify it during planning. Also confirms any temporary power needs for testing. In summary, a careful site inspection, a properly designed foundation, and verified power arrangement are essential. Doing this now will prevent costly rework and safety issues later.
Hello team, I will walk through the key installation steps: machine positioning, leveling and alignment, and electrical connection. Starting with the machine positioning, use the foundation drawing and anchor bolt layout to position the machine accurately. Bring in lifting equipment rated for the machine weight and follow the lift plan. Place rigging points according to manufacturer guidance to avoid distortion. Slowly lower the machine onto the foundation and align it roughly with the anchor holes. Keep communication clear between crane operator and ground crew, and use the tag lines to control rotation. Verify that the machine sits squarely and there are the required clearance for service access. Next, leveling and alignment. Once roughly positioned, install the anchor bolts but leave them slightly loose for fine adjustment. Use precision levels and feeler gauge to adjust the machine to within manufacturer tolerance. If the machine couples to other equipment, perform a shaft alignment using a laser or die indicator. Check both axial and angular misalignment for bolt or chain drive. Ensure correct center distance and tension. Record level and alignment readings as they are important for warranty and for future troubleshooting. Proper alignment minimize vibration, wear and energy loss. Finally, electrical connection. Only qualified electrician should perform wiring. Isolate the supply, verify voltage and phase rotation, and confirm the main disconnect is accessible. Strip and terminate cables per the wiring diagram. Secure strain relief and cable trays to avoid mechanical stress. Install any required starters, VFDs or control panels, and configure protective relays and overloads. Ground the machine to a low resistance earth point. After wiring, perform insulation resistance test and continuity checks. Reconnect power and test controls in a safe, stepwise manner. Energize control circuit first, then motor circuit. Watching for abnormal noise or heat. To conclude, careful handling during positioning, precise leveling and alignment, and correct electrical work are the backbone of a successful installation. With this complete, we can proceed to commissioning.
Hi everyone, so now I want to talk about the lubrication system check. And for this slide, I got 2 points. Point number 1 is we need to use the recommended lubricant, and point number 2, we need to make sure the lubricant fill the machine's level. Okay, so now we need to confirm the recommended lubricant type and fill level for bearing, gearbox and other component per the manufacturer manual. Then we need to verify that automatic lubrication pump, lines and metering device are installed and that there are no leaks or blockage. So we need to manually cycle greasing point where possible to ensure flow, and if oil bags or sumps are present, we need to check seal and breathers, and the document lubricant batch number and the initial fill date for maintenance record. The proper lubrication at startup prevent premature wear and overheating. For the next slide, I'm gonna talk about the trial run test. Firstly, we need to begin with dry runs, and secondly, we need to introduce light load testing. So with mechanical and electrical system verified, we need to perform a stage trial. So firstly, we need to begin with dry run, and then operate control with the machine unloaded to check motion, pads, limit switches, sensors and safety interlock. monitor for unusual vibration, noise or temperature rise. Then we need to introduce light load testing. So it's gradually increasing to normal operating condition while continuously recording motor current, vibration and temperature. So for this process, we need to use instrumentation to compare readings against expected range. If anything deviates, stop or broken, we need to investigate the machine. So we need to log all test results and compare them to acceptance criteria before signing it off. And for the final slide, I'm gonna talk about safety and training. So first point, we need to ensure all guard working, and secondly, we need to leave accessible documentation. So we need to ensure all guard, emergency stop and safety signage are in place. So we need to verify the lockout procedure are established and the local safety officer has approved the setup. So we need to conduct a toolbox talk covering emergency procedure, hazard zone and safe operating practice. You need to provide operator and maintenance staff with hand-on training for daily check, lubrication routine and basic troubleshooting. So we need to leave accessible documentation for the for example is contain the operation manuals, wiring diagrams and maintenance schedule. We also need to confirm contact point for technical support and warranty. In closing, throughout lubrication check, carefully stage trial runs and adequate safety control plus staff training, complete the commissioning and protect both personnel and equipment. Thank you.